Hello everyone, I am Mrs. K. Vanitha, Assistant Professor working in the Department of EC at K.S. Rangaswamy College of Technology. Today we are going to see the lecture on multiple access protocols in the course Computer Networks under the module Data Link Layer. So first of all, Media Access Control. IEEE has actually made this division for LAN. Media Access Control, it is the subdivision of the data link layer. The upper sublayer is responsible for flow and error control called a logical link control layer, and the lower sublayer is responsible for multiple access called as media access control layer. When two stations are connected on a same link called a multipoint or a multiple broadcast link, we need multiple access protocol to coordinate the access to the link. Many formal protocols have been devised to handle the access of the shared link. Media access protocol, multiple access protocols, it is divided into random access protocols, controlled access protocols, channelization protocols. Random access protocols are further subdivided into Aloha CSMA-CA, CSMA-CD and CSMA-CA. In this lecture, we are going to see about Aloha CSMA-CA, CSMA-CD and CSMA-CA. Media access control is otherwise called as random access. So each station can transmit when it desires. It follows certain procedure including testing of the state of the medium. The two features will give the name as random access. First, there is no scheduled time for the station to transmit. So it randomly access the medium if they finds idle so that it can send the data. It is otherwise called as random access. There is no rule to specify which station should transmit next. So each station compete with one another to access the medium, so that it is otherwise called as contention methods. Random access methods evolved from a very interesting protocol called as Aloha, very simple procedure called multiple access, which is used by very simple procedure called multiple access. Then the second method, improved method with the addition of procedure that forces the station to sense the medium, is otherwise called as carrier sense multiple access. Will be further divided into two methods, CSMA-CD and CSMA-CA. CSMA-CD is carrier sense multiple access with collision detection, and CSMA-CA is carrier sense multiple access with collision avoidance. Carrier sense multiple access with collision detection will tell what to do when the collision is detected. CSMA-CA tries to avoid the collision. Aloha, where we have pure Aloha and slaughtered Aloha. Pure Aloha, which is mainly used for designing, which was designed for a wireless LAN, but can be used on any shared medium. When a station sends the data, another station may attempt to do so at the same time, so that there may be a chance of collision, so that data will be discarded or gobbled. Pure Aloha, it's a very simple and simple but elegant protocol. Idea is that station can send the frame whenever it has a frame to send. So there is a possibility of collision, will be explained by means of this diagram. So if the station 1 has the data to send, it will send the data immediately on the channels. Similarly for the station 2, 3 and 4. So that for a particular time there will be a overlapping of the frames to 1.2, 2.1, 3.1, 4.1, so that the collision will be done, and so that the frame will be discarded. Similarly for the 2.2 and 4.2, only the 3.2 will be available at the output. Will be reaching at the destination. The chance of collision will be more. So it is obvious that we need to resend the frames if there is a collision. And Pure Aloha relies on acknowledgement. If there is no acknowledgement arrived at the sender site after a timeout period, it has to resend the frame. Pure Aloha dictates that when the timeout period passes, each station waits for random amount of time before resending its frame. Randomness will help to avoid collision. This randomness of a time period, waiting time period, is otherwise called as back of time. So which is used to prevent congesting the channel with retransmitted frames. And also, after a maximum number of retransmission attempts, Kmax, the station has to give up and try later. The vulnerable time for a pure aloha is 2 into frame transmission time. Throughput for the pure aloha is given by S, that is average number of successfully transmitted frames for pure aloha is S is equal to G into e power minus 2G. G is the average number of frames generated by the system, which is equal, so that S is equal to 0.184. 18.4% of the frames generated will be available at the destination as the successfully transmitted frames. Slaughtered aloha. Pure aloha has the vulnerable time of 2 into frame transmission time. There is no rule that when the station can send. So soon after the station has started or another station has finished, if a station has a frame, it will be sending the frame. But the slaughtered aloha was invented to improve the efficiency of the pure aloha, where we divide the entire time period into slots with the frame transmission time. One frame transmission. Each station can send the data only at the beginning of the time slot, so that the vulnerable time of the pure aloha, slaughtered aloha, will be 1/2 of that of your pure aloha. Throughput will also be improved, that is 36.8% of the frames will be reached at the destination successfully. Carrier sense multiple access. The next method, the random access, is the carrier sense multiple access. It will sense the medium. If it finds idle, it will if the station decides to send, it will send. So the possibility of the collision will be reduced. Moreover, it has the possibility of collision still exists because of propagation delay. It is well explained by the diagram by means of a space-time model. If A has the time to send, has its frame to send at T1, at T2, C has not heard the bits which are transmitted from the A. So it finds the channel is silent, so that it will send the first bit of the frame. So after a particular time period T1, that is A's first bit and the C's first bit will be joined and it is collided. The possibility of collision will occur. So the vulnerable time for CSMA is the propagation time. The time needed for it is the time needed for a signal to propagate from one end of the medium to another. From the CSMA CA, 3 methods have been devised which tell what should the station should do if the channel is busy, what should the station should do if the channel is idle. I persistent method, non-persistent method, and P persistent method. I persistent method, after a station finds the line is idle or a channel is idle, it sends the frame immediately. Non-persistent method, it waits for a random amount of time, then it senses the line again, so that it will send the frame. It reduces the chance of collision. P persistent method, where the entire channel will be divided into time slots, which is equal to each slot will equal to or greater than the maximum propagation time, so that it further reduces the chance of collision and improves the efficiency. Carrier sense multiple access collision detection. We can detect the collision in the wired medium. A station monitors the medium after it sends a frame. If the frame transmission was successful, if so, station has finished. However, if there is a collision, the frame will be sent again. It is further explained by this CSMA CD diagram. That is, A will send the data at T1, C will send the data at T2. At particular point, both data will be joined and collided. Collision occurs. So that the frame transmission time will be T4 minus T1 for A and T3 minus T2 for D. minimum the frame transmission time must be at least 2 times the maximum propagation time. Carrier sense multiple axis with collision avoidance. We can detect the collision in case of wired network where the energy is doubled, that is the when there is a collision, its own energy and the collision and the energy which is received from the second station. But we cannot detect the collision for the wireless network. Only 5 to 10% of additional energy will be received by the second station. So we can avoid the collision by following the procedure in CSMA CAs with 3 strategies: the interframe space, contention window, acknowledgement. It is further explained by this diagram. Timing in CSMA CA, that is, if the channel station wants to send the data, continuously sends the medium. If it is busy, it waits for some time period till the channel finds out idle. It waits for interframe space, time called as interframe space. Further, it is wait for the contention window. So yeah, after that it finds the channel is idle. It picks the random time slot of the contention window to send the frame. Interframe space, it is further explained. It waits for a period called as interframe space. If the channel is idle, it has to wait time equal to the contention time, and also it performs the prioritization of the stations for sending the frame. If it has shorter interframe speed, it has the highest priority. Contention window will be divided into time slots. So a station is ready to send the data, it has to pick the random number of slots for the first time, but it doubles each time. The station cannot detect the idle channel after IFS time. If the station finds the channel busy, it does not restart the process, but it stops the timer, restart it when the channel is sensed as idle. And also it gives the priority to the station with the longest waiting time. So with this we can have some MCQs. First two are: the sublayer of the data link layer is responsible for multiple access resolution. Random access protocols are otherwise called as. The answers are: sublayer for the data link layer responsible for multiple access, media access control. Random access protocols are otherwise called as contention methods. In Pure vulnerable time is 2 into frame transmission time. Maximum throughput for the Pure is 18.4. The maximum throughput for slotted is 36.8. The vulnerable time for slotted compared to Pure is half. Vulnerable time for CSMA CA is equal to the propagation delay. One persistent CSMA, when the channel is idle, immediately sends the frame. Non-persistent CA, if a channel is busy station, if the CSMA CA, the waiting time for a retransmission is divided into slots in contention window, waits a random time before retrying. So that's all about today's lecture. Thank you for your patient listening.